So previously we have discussed one problem for finding the transfer function of a signal flow graph using the Mason's gain formula. Now we will discuss one more example so that you can be familiar with the solving the problem for finding the transfer function if signal flow graph is given for you. So this is the problem: find the overall gain C of s by R of s for the signal flow graph shown in figure below. This is the signal flow graph here. So here the input is R of s and output is C of s. So transfer function is C of s by R of s we have to find out. So transfer function we can find using the Mason's gain formula if signal flow graph is given. So Mason's gain formula equal to 1 by delta summation k pk delta k. Okay, na? So this one is for you that formula. So here we have total 8 nodes are there. The input node is 7 and the 8th node is the output node which is going to collect the output. So node 1, node 2, 3, 4, 5, 6, 7 and 8. Total 8 nodes are there. And the direction is given. In which direction signal is going to flow? Either in the forward direction or in the reverse opposite direction. So the forward path straight away you observe from first node to 8th node. See, node 1, node 2, node 3, node 4, node 5, node 6, node 7 and node 8 all are moving in the forward direction only. So that is the first forward path. So first find the individual forward path gain. See, forward path gain. First find out what is forward path gain. So from that you will get what is the k value also. So first forward path is, it is going to move from node 1 to all nodes, means it is going to touch all nodes. So in previous case we have observed that for finding the delta 1, there you have observed only one forward path is there. So there also you have considered the first forward path as the same one, means see, anyone will choose this one only as a first forward path. You can choose other also, no problem. So here, so this is R of s initial. So this is the C of s is the output. So this is input and C of s is the output. So direction you observe. So 1 to 2 forward direction, 2 to 3 forward direction. From here 4 to 5 forward direction and 5 to 6, 6 to 7 and 7 to 8. So all are in a forward direction only. So now write the transmittance. 1 to 2, what is the transmittance? It is 1. 2 to 3, it is G1. 3 to 4, it is G2. 4 to 5, G3. 5 to 6, the gain is G4. And 6 to 7, the gain is G5. 7 to 8, it is 1. So forward path gain P1 equal to, so multiply all the transmittance. So 1 into G1 into G2 into G3 into G4 into G5 into G1. So which will be equal to G1, G2, G3, G4 and G5. So this is the one forward path gain. Okay, first forward path gain. Now observe any other forward path is there. So 1 to 2, here we have another path. This one already we have observed. Now observe 1 to 2 and 2 to 3. See, this direction, this arrow direction is moving in the forward direction only. So 1 to 2 and 2 to 5 and 5 to 6, 6 to 7 and 7 to 8. This is the another forward path. So here nodes 3 and 4 are not touching. Directly from node 2 to node 5 it is going to reach. See, this is, so you draw the same shape so that you can find what are the what is the non-touching portion of the graph which is not touching that forward path, particular forward path. 2 to 5 and 5 to 6, 6 to 7 and 7 to 8. So here it reaches output. So this is R of S. So 1, 2, 5, 6, 7 and 8. So observe the same shape you draw 1 to 2 and 2 to 5 it is going in this direction. So 2 to 5. So now we will see the arrow direction. See arrow direction 1 to 2 in the forward direction and observe 2 to 5 in this forward direction, and see at the same time you will write the transmittance. 1 to 2 it is 1, and 2 to 5 it is G6, and 5 to 6 G4, and 6 to 7 G5, and 7 to 8 it is 1. So now multiply all the transmittance. So P2 equal to, see, 1 into G6, G4, G5 into 1, that is G4, G5 and G6 is the second forward path gain. So now you have observed another path from 2 to 5. So another path is not there from 2. Next 1 to 2, move to next node 3. So 3, if you observe in this direction, see there is a path in opposite direction. So it is not a forward path. Here also you can observe. So it is moving in the opposite direction. So it is not a forward path. Move to 4, 5, 6. So 6 you observe in this direction. It is moving in the opposite direction. So we have only 2 forward paths. So number of forward paths, that is k equal to 2. So in previous problem k equal to 1. So here we got k equal to 2. So next we have to move to find what is the individual loop gains. Okay, individual loop gains. See, individual loop gain calculations. So you observe the loops. So 2 to 3 forward path, 3 to 4 and 4 to 5. Observe here, it is moving in the same direction. So it is not a loop. From node 2 there is no loop, and 3 to 4 and 4 to 5 one loop, 3 to 4 and 4 to 3 one loop is there. So the same you can represent here, 3 to 4. So 3 to 4, 3 and 4 it is moving in this direction, and 4 to 5 we have a path, that is feedback is there, minus h1, this is minus h1 and this is g2. So let it be some p11 equal to minus, so equal to minus, so we'll write, so what is this one? This is h1. See, 3 to 4, 3, 4 in the same direction, 3 to 4 it is G2, and 4 to 3 minus H1, minus H1. So P11 equal to, so P11 equal to minus G2 H1, minus G2 H1. So one loop, and next observe another loop, 3 to 4 and 4 to 5 and again 5 to 3. Another loop is there. So 3 to 4, see 3 to 4, 3 to 4 and see 3 to 4 and 4 to 5. 3, 4 and 5. So 3 to 4, the gain is G2. So 3 to 4 and 4 to 5. 3 to 4 and 4 to 5. So 3 to 4, the gain is G2, G2, and 4 to 5, the gain is G3, and again 5 to 3 minus H2. So P21 equal to minus G2, G3 and H2. So another loop. So 3 to 4 is covered, and 3, 4, 5 is covered, and move here. 6 to 7 forward path and 7 to 6 feedback path is there. So another loop is there. So what is that loop? 6 to 7. 6 to 7. 6, 7. So 6 to 7, the gain is G5, and 6 to 7 it is minus H3. So P31 equal to minus G5 H3. So these are the individual loops. 3 loops are there. So now we have to find out whether there are possibility all possible combinations of two non-touching loops. So two non-touching loops, two non-touching loop gain, two non-touching loop gains. So what are the loops here? Observe, this is one loop and this is another loop and that is the third loop. First loop and second loop, observe. Nodes 3 and 4 are there. So here 3 and 4 are there, means they are touching loops. And next this one, first loop and last loop. There are no common nodes, 3, 4 and 6, 7. There are no common nodes. So here you have to represent that two non-touching loops. So what are the two non-touching loops? 3 to 4. This is the first possibility, first possible combinations. So this is G2. So this is minus H1. Another loop is 6 to 7. 6 to 7. This is G5. And this is minus H3. Through loops. See, there are no common nodes. So here we have to find the product of these two non-touching loops. So we are going to assign one name. See, now you can observe, previously in previous problem there are no two non-touching loops. Here there are two non-touching loops are available. See here I have given one, see 1 1 P2 1 P3 1. That one indicates that a single individual loops. So here we have taken 2, means 2 indicates it is the product of two non-touching loops. Here 1 indicates first product of two non-touching loops. So these two non-touching, what is this one? This is the loop. What is that name? P11. P11 product, you have to multiply. 6 7 means P31. P31. So which is equal to, what is P11? P11 is minus G2 H1 multiplied with P31, that is minus G5 H3. So P12 equal to product now G2 G5 H1 and H3. So this is the first possible combination of two non-touching loops. Now 3 is compared with the last one, completed. Now this one 3 4 5. Observe 3 4 5 with the last, these two no common nodes, 3 4 5, here 6 7. So you draw the two loops 3 4 and 5. 3 4 5. Okay, now 3 2, this is minus H2 G2 G3. This is 6 7. 6 7. This is G5. This feedback path minus H3. So previously I have named it as P12. Now we will give a name as P22. P22 equal to P21. P21 multiplied with P31. What is P21? Just you multiply all these individual. So you multiply all that transmittance. Same thing you have done here. So which is equal to minus G2 G3 H2 multiplied with P31. P31 is minus G5 H3. So P22 equal to G2 G3 G5 H2 H3. So now check for, is there any possibility of three non-touching loops? See, there are no three non-touching loops, because see 3 4 here these two are touching loops. So there are no three non-touching loops are there. So now we have to find out what is delta. Then we have to find out what is delta K. So what is delta? The formula 1 minus sum of individual loop gains plus sum of gain product of 2 non-touching loops minus sum of gain product of 3 non-touching loops plus so on. So now first we find out what is delta. Say delta equal to, say delta. Now we will see here delta. Say delta equal to 1 minus sum of individual loop gains. What are the individual loop gains? P11 plus P21 plus P31 plus sum of gain product of all possible combinations of 2 non-touching loops, that is P12 plus P22. Now substitute what is P111, what is here P12 is P12 plus P22. Substitute all these things here. So delta equal to, now observe, minus of this P11 minus G2 H1 minus G2 G3 H2 minus G5 H3. This portion is completed here. Individual loops plus say plus P12 is, so both are plus, so directly I will write here plus G2 G3 G2 G5, see G2 G5 H1 H3 plus the last term G2 G3 G5 H2 and H3. So delta equal to, finally the delta equal to 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 H1 H3 plus G2 G3 G5 H2 H3. So this is the delta. This is delta. So delta is completed. Next delta k we have to find out. So delta k equal to delta for the portion of the graph which is not touching that particular forward path. So here we have 2 forward paths are there. So this is the first forward path. See here there is no portion of the graph which is not touching this 8 nodes. So delta 1 equal to 1. Why you write here? There is no part of the graph. There is no part of the graph which is not touching. So which is not touching first forward path. First forward path. Now delta 2 we have to find out. Delta 2 is the part of the graph which is not touching second forward path. See, we have some path. This is the second forward path. Second forward path here 3, 4 is not touching here. So 3, 4 a loop is, a graph is formed here. So right here the part of the graph. The part of the graph which is not touching second forward path. second forward path is, you show that graph here. What is that graph? That is why we have said here, see 3 and 4 are missing here. 3 and 4 are missing. So for that missing nodes, any graph is formed. A graph is formed. You show that graph here. So this is that graph. What is that graph? 3 to 4. See 3, 4, and there is a loop. 3 to 4. The gain is G2. J2. This is minus H1. So what is delta 2? So delta 2 equal to 1 minus sum of individual loop gains. So only one loop is there here. So which is equal to 1 minus individual loop, that is minus G2 H1. So delta 2 equal to, so delta 2 equal to 1 plus G2 H1. So previously we have find what is delta for this whole graph. Now delta 2 only for the part of the graph which is not touching the second forward path. 3 and 4 nodes are not touching here. So from that any graph is formed. You have to observe here, graph is formed 3 to 4. One closed path is there here. So if any closed path is there, you draw that, and for that we have to find out delta. What is delta? Delta equal to this 1 minus a sum of individual loop gains plus product of two non-touching loops. Here there are no two non-touching loops. So directly we will get delta 2. So now everything is there. So finally we have to find what is transfer function using Mason's gain formula. So Mason's gain formula is given by, see, Mason's gain formula. Transfer function TF equal to 1 by delta summation k pk delta k. See here, first forward path G1, G2, G3, G4, G5. Okay. C of S. So C of S by R of S equal to 1 by delta. See 1 by delta summation k. K value how much? K equal to 2. So pk delta k. So this one I will write here P1. What is that P1? P1 equal to G1, G2, G3, G4 and G5. G1, G2, 3, P2. P2 equal to G4, G5, G6. Now C of S by R of S equal to, substitute here P1, K equal to 2. P1 delta 1 plus P2 delta 2 by delta. So which is equal to P1. What is P1? Here we have written now. So G1 see, which is equal to P1 G1, G2, G3, G4, G5 into delta 1. Delta 1 equal to 1. So 1 plus P2. What is P2? G4, G5, G6 into delta 2. Delta 2 is 1 plus G2 H1. 1 plus G2 H1. Completed. Now delta. This is the portion delta. Delta you write here. So 1 plus G2 H1 plus G2 G3 H2 plus G5 H3 plus G2 G5 plus 1 plus, so G2 G5 okay, here it is missed, so G2 G5 H1 H3 plus, you write that term here. So here I have erased that one. So this gives, see here one more term is there here. You copy that term here. This is erased. So this is the transfer function for the given system. Okay, for the given system. So in this way you can solve some problems and find a solution for the given signal flow graph for finding the transfer function using the Mason's gain formula. Madam.